Hello and welcome to this weather topic video. This is indeed the re-upload of the tornado types video here, re-uploading it and redoing it because the aspect ratio when I recorded it was vastly incorrect. There was a bunch of black space around where the around where my slide was, and I didn't realize that until I uploaded it. So here I am redoing this video. So we're going to be looking at tornado types with this weather topic video. This is going to be looking at different tornado shapes and sizes, as well as notables of those sizes. So what is a tornado type? A tornado type is more so broadly described as the size and shape that a tornado can be. This can be anywhere from a very thin and tall looking rope to a very, very well defined 3/4 mile wide wedge. It all depends on how the condensation funnel forms. There is no way of predicting what shape a tornado will be until that condensation funnel happens. And it is still not known how each type happens. I'm going to be covering 4 on this chart of 20 here. They're going to be grouped together, and as well as an additional one, the multi-vortex or vorticity noodle. So these 5 in total are going to be the rope and wire, the cone and V-shaped more commonly known as drill bits, the wedge, the bowl-shaped, which is more so wedge than anything else. Bowl-shaped will be going over all of the types of condensation funnel that did not reach the ground. And again, like I said, the multi-vortex and vorticity noodle. Our first is the rope or wire. These are very thin, as the name might suggest, and because of this, they usually appear taller than the average tornado. However, this is almost never the case. The cloud base is not any higher, nor is the ground any lower usually. And more so, if anything else, the rope is a stage in a tornado's life. This stage is actually called the rope out, where the tornado has essentially weakened to the point where it's probably EF1, EF0 strength, and is in its death throes, basically. It would be soon after the rope out that the tornado would completely dissipate. The cone and the drill bit, again V-shaped on this list here, I'm going to lump in with the cylinder just because it is a pretty close resemblance of the two. There's not much modification to a cylinder you need to get a cone. In the grand realm of things that I've seen, the cone and the V-shaped, again, drill bit, most commonly has a cloud base that is 2 times wider than the ground base. And the cloud base would not be the wall cloud, that would be actually where the condensation funnel starts, so below the wall cloud. Generally, the cone and drill bit is the most common shape of tornado, and why this is a fantastic question. However, it is not known why. Some notables of the drill bit and cone are the Manitoba, Canada F5 from 2007. This is Canada's first and only F5, as it would go to the Enhanced Vujita scale, if not mistaken, this same year, or wouldn't be until a few years later. I cannot remember. Another example of a cone is the Hanover F4, Hanover, Indiana, from the 1974 super outbreak. Here we have a very distinct, very well defined squarish wall cloud with the tornado, with the classic little curve in the condensation funnel. That's a very, very classic imagery of a tornado. The Sailor Park F5, also from the 74 Super, is a great example of a drill bit as well. Now, the size of a tornado does not mean that it is super strong. So you can have an F5 cone and an F5 drill bit, obviously, but you can also have, say, an EF2 wedge. Those wedges are still notable enough because they at least managed to achieve that size. But that aside, we also have the Chickasha, Oklahoma EF4 from the 2011 May tornado outbreak. Sailor Park is Ohio, by the way. Forgot to mention that. And lastly, a very wide cone is the Andover, Kansas F5 from 1991, from a very famous video of the Andover tornado. Very soon after it appeared, the Andover tornado appeared like this, it would appear as a very wide cylinder. You can also describe a very wide cylinder as a wedge. The wedge, generally, if it is a true wedge, so the shape is decreasing as it gets closer and closer to the ground, has a cloud base only around 50% wider than the ground base. Now, generally, the ground base, which would be the true path width, is wider than 3/4 of a mile. That's the general trend that I've seen when a tornado is described as a wedge. By no means, and this is also the case for the cone and drill bit, is this the rule. A cone does not have to have the cloud base 2 times wider than the ground base, and both of these first 2 points are not strict requirements for a wedge tornado. This is just how they appear. The wedge is also generally the most well-known tornado. There are there are just many tornadoes that are well known just because they achieved this size, and for good reason. Wedges usually only happen when a storm has enough ingredients and in the right environment to produce that size of a tornado. It is generally linked to more volatile environments and with discrete, so by themselves, supercells. Because a supercell is by itself, it's able to take advantage of everything around it. Some notable wedges include the Bridge Creek Moor F5 in Oklahoma from 1999. This tornado was equal to or more than, I should say, 1 mile wide at its widest. This thing was also very consistent in strength, or in size, I should say, not in strength. Next is the El Reno, Oklahoma EF3, or if you want to go off Doppler indicated wind speeds, which you should, it was an EF5. This is from 2013 again, and is the widest tornado ever at 2.6 miles wide. It's at this point that a tornado doesn't even look like that it is a tornado. It just looks like a mess of rain and a wall cloud maybe. But trust me, in this photo there is indeed a tornado on the ground. The Parkersburg EF5 from 2008, which I always get Ohio and Iowa mixed up in my mind because I'm stupid, so I forget which state Parkersburg is in. I'm very sorry about that. Measured in at 1.2 miles wide. This tornado, despite being EF5, isn't normally talked about, surprisingly, or at least isn't brought up in the realm of EF5 tornadoes. Another 5 is the Brandenburg, Kentucky F5. This tornado is seen here as a wedge, and this is from the 74 super outbreak. This tornado was known to apparently vary in width by a fair bit, and back in 74, the average width was the measurement used instead of the true maximum width. Why this is, I have no idea, but even then I could not find an average width for the Brandenburg F5. The title for the scariest tornado image I've ever seen would go to the Hackleburg, Mississippi EF5 from the 2011 super outbreak. A very wide cylinder here is seen at more than 1 mile wide. Next up, and our last one here to talk about, is the Bassfield, Mississippi EF4. Seen here in this photo just west of the town of Seminary, Mississippi, this tornado reached 2.25 miles wide. That is the third widest ever recorded, only behind the 2.4 mile wide Hallam F4 from 2004 and the El Reno EF3, which I have right here. This tornado was definitely a lot easier to make out than El Reno, and is not a case of multi-vortex like El Reno was. The bowl-shaped is next, and again, like I said in the beginning, combining all condensation funnel types that do not touch the ground here. So that is the cigar, the convex, the bulb, the bowl-shaped, the truncated cone, and the wedge, because a bowl-shaped is more of a wedge than anything else. Specifically looking at the bowl-shaped, generally these tend to be wedges, but again, like I've said, just the condensation funnel has not reached the ground. Condensation funnels do not need to reach the ground in order for it to be a tornado. And we will see that with our second notable of the bowl-shaped. But here is our first notable. This is the DePaul, Indiana F5 from the 74 super outbreak. It's seen here again with a condensation funnel that is indeed there, but looks more so like a very ragged wall cloud, really trying to get itself up to shape. But again, don't be fooled, that is indeed a tornado. And this is what I mean by no condensation funnel does not mean no tornado. A power flash is seen here in this photo from the Ringgold, Georgia EF4 from the 2011 Super. A power flash means that a tornado is indeed on the ground and is throwing debris around. What happened is that either winds were strong enough to snap a power cable, or what usually happens is that a piece of debris snaps a power line. That would mean that a tornado is indeed on the ground, as there is debris being flung around. The multi-vortex or vorticity noodle producer I am kind of messily combining here. If you're talking about a purely made up of multiple of vortices tornado, it can be anywhere from a cone to a wedge in shape. And this can be the same for a vorticity noodle producer. The vorticity noodle is, in short, caused by the fact that air going into the inflow notch of a tornado rotates there in super thin columns, in clockwise and counterclockwise columns, one after the other. So it's CW, CCW, CW, CCW. You get the idea. The tornado, which 98% of the time rotates counterclockwise in the northern hemisphere, wants the counterclockwise rotations. So either the clockwise rotations are simply dissipated because they're so weak, and the counterclockwise ones are also really weak too, or they are combined, or they are thrown out and away into the tornado, and that can combine with it, which would form a sideways vorticity noodle. A sideways vorticity noodle is one of the very few signs, in my opinion, that a tornado is violent, so EF4 and above. I have never seen, to this day, an EF3 or below producing any sort of vorticity noodle. Now, I do think that this is a coincidence, but that still is the trend where that, again, have not seen an EF3 produce a vorticity noodle. Some notables of either purely multi-vortex tornadoes or vorticity noodle producers are the Xenia, Ohio F5 from the 74 super outbreak. This tornado is purely made up of multiple vortices. and is seen here looking very, very diffuse. And that is because within this broad debris cloud and overall condensation funnel, there are multiple vortices in here. The Arab Alabama EF4 from the 2011 Super was a 190 EF4, which is seen here looking very consistent in contrast, but is seen with two funnels trying to fight it out. They either resolve their differences or one wins over the other in this next image of the tornado, where you see the classic stovepipe. The stovepipe is different from a cone because it has a wide base, but then it straightens out. The funnel straightens out as it reaches the ground, as it goes to the ground. And in this photo here, we either have a warped satellite or a very long and interesting vorticity noodle here. Another very, although pretty messy looking tornado, but very consistent in appearance, is the Cordova, Alabama EF4, again from the 2011 Super. A 170 mile per hour EF4 is seen here producing that sideways vorticity noodle here. Now, vorticity noodles do not reach the ground per se, more so they're just kind of lifted up and away from the ground. Probably the most infamous of all vorticity noodle producers is the Tuscaloosa Birmingham EF4, again from the 2011 Super. Seen here with, let's see, one, two, ignore the smudges. Those are actually drops of rain on the camera. Three, maybe four up here, though three at least vorticity noodles. This tornado was a monster 190, very well documented. And that is all that I have for tornado types. Again, this is a re-upload of it. I am sorry about having to redo this one. I didn't really want to, but I felt like I needed to because the aspect ratio on the original of this is pretty bad. So hopefully it's a lot better looking now. I hope to see you all in the next video. Thank you so much for watching until the very end.